Along with derivatives, integrals is a fundamental concept of calculus. It is often referred to as the antiderivative, as it is the opposite of the other one's concept. Integrals is used to find the area underneath the graph of a function and the x-axis. There are two classes of integrals: definite integrals, which have upper and lower limits, and indefinite integrals, which are written without limits. Let's first elaborate indefinite integrals. When we derive 2x, it becomes 2. But when we integrate this, it can be 2x, 2x plus 4, or 2x plus any constant. Below are the integral rules to follow for instances such as this.
The constant integral rule follows the formula in which the integral of k dx is equal to kx plus c. The plus c in these formulas and our final answer is important to emphasize that the function which has been derived may have a constant. First example is the integral of 52 dx. This simply becomes 52x plus c by following the formula. Number 2. Second is the integral of 9 dx, which is equal to 9x plus c. Next, the power rule follows this formula. The integral of x raised to n dx is equal to x raised to the quantity n plus 1 all over n plus 1 plus c. Let's have our first example. Given here is the integral of x raised to 4 dx. As we follow the formula, let's just copy x on the numerator, then add 1 to the exponent, which gives us x raised to 4 plus 1 all over the exponent plus 1 as well. So we'll have 4 plus 1 in the denominator. This becomes x raised to 5 over 5 plus c for our final answer. The same goes with our second example. We have here the integral of 5 square root of x dx. Let's separate the constant here. This becomes 5 times the integral of square root of x dx. By turning this into exponential form, it becomes 5 times the integral of x raised to 1/2 dx. Now let's follow the formula. Let's copy 5 and integrate this. It will give us 5 times x raised to 1/2 plus 1, which is 2 over 2, all over 1/2 plus 2 over 2 as well. Through simplifying, this becomes 5 times x raised to 3/2 all over 3/2, so we'll get 5 square root of x cubed all over 3/2. Let's multiply the denominator of the fraction. The denominator to our numerator, this becomes 10 square root of x cubed all over 3 plus c as our final answer. Now, let's move on the exponential rule. Here we'll follow the formula wherein the integral of e raised to kx dx is equal to e raised to kx all over k plus c. To further elaborate this, let's have our examples. First, in the integral of e raised to 5x dx, by following the formula, let's first copy the given function, then put exponents constant in our denominator plus c, which gives us e raised to 5x all over 5 plus c. Let's now have our second example. We are given the integral of 8 e raised to 2x dx. First, let's separate the constant. So we'll have 8 times the integral of e raised to 2x dx. Copy the constant, then as we follow the formula, we'll copy e raised to 2x for our numerator and have 2 as the denominator. The greatest common factor here is 2, so we can cancel out 2 and 8 will become 4. Therefore, we'll get 4 e raised to 2x plus c. Lastly, for the basic rules, we have the formula, the integral of 1 over x dx is equal to ln x plus c. We have here the integral of 1 over 3x dx as our first example. First, we'll separate the constant 1 over 3 multiplied by the integral of 1 over x, which we said is equal to ln x. So 1 over 3 times ln x is equal to ln x over 3 plus c as our final answer. For our second example, the same process happens. We have here the integral of 1 over 7x dx. We'll have 1 over 7 times the integral of 1 over x, which can be simplified to ln x over 7 plus c. Now, let's move on to trigonometric integrals. The integral of the trigonometric identities are just the opposite of their derivatives, wherein the integral of sine x dx is equal to negative cosine x plus c. The integral of cosine x dx is equal to sine x plus c. The integral of secant squared x dx is tangent x plus c. The integral of secant x tangent x dx is equal to secant x plus c. The integral of cosecant x squared dx is negative cotangent x plus c. And the integral of cosecant x cotangent x dx is equal to negative cosecant x plus c.
Let's now integrate the trigonometric functions by using the mentioned integrals. Number 1, we have here the integral of 1 over 1 minus cosecant squared x dx. First, let's simplify the identity in the denominator. This will give us 1 over sine squared x dx. 1 over sine x is cosecant x, so we'll have the integral of cosecant squared x dx. According to the trigonometric integrals, the final answer is negative cotangent x plus c. For our second example, we have the integral of cosecant squared x cosecant x dx. Let's simplify them first. Cosecant squared x is also equal to 1 over sine squared x. Then, let's copy cosine x. Next, let's expand this. So we'll have the integral of 1 over sine x times 1 over sine x times cosine x dx. Multiply the two, so it will be the integral of 1 over sine x times cosine x over sine x dx. As we simplify, this will become the integral of cosecant x cotangent x dx, which is negative cosecant x plus c.
Let's move on to integration by substitution. Here, we use u to substitute to a function and integrate it to make the process less complicated. We have here the integral of square root of the quantity 8x plus 7 dx. Here, we are going to let u be equal to 8x plus 7 and du be 8 dx. Since the derivative of 8x plus 7 is 8, let's equate dx here to du over 8 so that we can use it for the next processes. So, let's now substitute. The integral of square root of u times du over 8, let's separate 1 over 8 as our constant, times the integral of u raised to 1/2 du. We can now integrate. We'll have 1/8 times u raised to 1/2 plus 1, which is 2 over 2, all over 1/2 plus 2 over 2. Then, we'll get 1/8 times u raised to 3 over 2 over 3 over 2. To simplify, we'll have 1/8 times 2 square root of u cube over 3 equals 2 square root of u cube over 24. Cancel 2 and 24 will become 12. So, we'll have square root of u cube over 12 plus c. Finally, let's substitute the function. The square root of quantity 8x plus 7 cube all over 12 plus c. Let's try again on our second example. We are given the integral of the quantity 1 minus sine squared x times cosine x dx. Here, we will let u be equal to sine x. The derivative of it is cosine x dx. Now, let's integrate. We'll have the integral of the quantity 1 minus u squared du. In this given, the value of du is equal to our given, which is cosine x dx. So, we don't need to transpose or equate. Moving on, as we integrate, we'll have u minus u cube over 3 plus c. Lastly, just substitute. Sin x minus sin cube x over 3 plus c is now our final answer.
The next concept is called integration by parts. This is used to integrate the product of two different functions. Here, we follow the formula uv minus the integral of v du. And we use what is called the LIATE rule, or what I call the Liate rule. It stands for logarithmic inverse trigonometric, algebraic, trigonometric, and exponential. To further elaborate, let's have an example. Let's have the integral of ln x over x squared dx. First, we should know which of the two functions will be used as u and dv. The Liate rule discussed earlier is applicable to determine the value of u. Here, in our example, ln x is logarithmic and 1 over x squared is algebraic. In our rule, logarithmic comes first. Therefore, we will have ln x as u and 1 over x squared as our dv. Now, let's derive ln x to get du. This will be 1 over x dx or simply dx over x. Then, let's integrate 1 over x squared dx or dx over x squared. V is equal to x raised to negative 1 over negative 1 or simply negative 1 over x. Next, we will follow our formula. So, we'll have u, which is ln x, times v, which is negative 1 over x, minus the integral of v, which is again negative 1 over x, times du, which is 1 over x dx. Next, let's simplify. We'll have negative ln x over x plus the integral of 1 over x squared dx. 1 over x squared will become x raised to negative 2 dx. Now, let's integrate. Copy negative ln x over x plus x raised to negative 2 plus 1 over negative 2 plus 1. This will be negative ln x over x plus x raised to negative 1 over negative 1. The second term can be simplified to negative 1 over x, which will be negative ln x minus 1 all over x plus c, our final answer. Let's now try the integral of 2xe raised to x dx. Let's first separate the constant. So we'll have 2 times the integral of xe raised to x dx. To get u, let's first determine which of the two comes first in the Liate rule. As noticed, algebraic comes before exponential. So our u will be x. Therefore, du will be dx. Then, dv will be e raised to x dx, in which v will become e raised to x. By following this formula, we'll have xe raised to x minus the integral of e raised to x dx. Now, it will be 2 times the quantity of xe raised to x minus e raised to x after integrating. Let's distribute 2 and so we'll get 2xe raised to x minus 2e raised to x plus c as our final answer. The aforementioned concepts are under indefinite integrals. Let's move on to definite integrals. Definite integrals are allowed to be computed in terms of indefinite integrals. Since if we say that f of x is the indefinite integral for f of x, then the integral of f of x dx from a to b is equal to f of b minus f of a. Let's have some examples to further explain this.
We have here the integral of x squared dx from 1 to 4. First, let's integrate the function. The integral of x squared is x cubed over 3 from 1 to 4. To get this, let's substitute b to the function. Then, subtract the value that you will get when you substitute a to the function, which in this case is 1. So 1 cubed is still 1 over 3. This results to 63 over 3, which gives us 21. For our next example, we have the integral of ax squared plus 3 dx from 0 to 5 is equal to 670 over 3. We are asked to solve for the value of a. To get this, let's first integrate the given function wherein a is a constant. So using the rules before, we'll have 670 over 3 is equal to ax cubed over 3 plus 3x from 0 to 5. Then, let's substitute 5 to x. 670 over 3 is equal to 5 cubed, which is 125a over 3 plus 3 times 5, which is 15. Next is to substitute 0 to the function, which gives us 0. So we don't have to write it. Now, the LCD of 125a over 3 and 15 is 3. So we'll have 3 as the denominator, divided by 3 is 1 times 125a is 125a. Then 3 divided by 1 is 3 times 15 is 45. Then, multiply both sides by 3 to cancel out their denominators. This will leave us with 670 equals 125a plus 45. Transpose 45, so we'll have 670 minus 45 is equal to 125a. 625 is equal to 125a. Divide both sides by 125. Therefore, the value of a is 5.